So 11.5 deals with our problem solving. And I really like this first problem because if I haven't talked about it yet, back in college, one of the ways that my fraternity made money.
Shirts.
Yeah, screen printed.
Yeah.
So there's two different ways you can print shirts. You can screen print, or you can like digital press it, and it essentially like irons it on. So screen prints use actual ink, like goopy liquid ink that comes in a bucket. So this company has decided they're going to have a round green logo. Obviously, there'd be more than just a green circle, but for our purposes, we're just looking at it as a green circle logo. They're deciding whether to put one of them on the shirt, 4 of them on the shirt, or 9 of them on the shirt, and they want to see which one would have more or less ink. They want to compare how much ink this uses. So, if we want to talk about how much ink or how much space something takes up, what are we actually talking about? Area. Area is how much space something takes up. Alex, do you have your notes, bud?
Oh, yeah.
Okay, get them out. I've asked that about 4 times. So, we need to find the area of all 3 of these. Now, you probably have this work written down, maybe, but the question is, do you really understand what was happening? So, when we look at this first circle, and I'm going to use cards to help check who really does understand what's going on, what is my area formula? Ashley, do you know what my area formula for a circle is? Starts with pi.
A equals pi times r to the 2.
R squared, yeah, and that R, what's that R represent? What is the R? It's the beginning of a word. You can phone a friend if you need. Radius. So, what is the radius, Lainey?
It's like half the diameter.
It's half the diameter. The diameter is the entire distance across, so half the diameter. Really, the definition of the radius is from the center point to the edge. So, if you don't have that drawn on your paper, go ahead and draw that right now. Now, for my big circle, how can I figure out what its radius is? Jennifer? Yeah, we know that the distance all the way across is 24, so the distance halfway across we divide by 2, like Jennifer said, and we get 12. So now that area, Marion, question or answer?
I don't know if it's a big deal, but someone made us put the 12 on that.
It doesn't matter. Yeah. So then we set up area is going to equal pi times, what's my radius? 12, so I put 12 squared.
Times.
Did she tell you that we're going to leave all these in terms of pi?
Yeah.
Do you know why?
Yeah,
I
I
know.
know.
I
Because
know.
talking about that.
Okay, because if we do it in in terms of pi, it's first off simpler, and if we didn't, we would use 3.14, not like the whole thing.
Yeah.
So it's more exact.
What am I doing with these 3 images? I'm looking at them to compare. All I want to do is compare. And since all I want to do is compare, if each of these is in terms of pi, I can compare them all because they're all in the same form. So 12 squared, what's 12 times 12?
44.
44.
Ooh, close.
48.
144
Oh.
pi, but I'm not done until I have a label. What's my label here, Nick?
Inches squared.
Inches squared. Is Isol not here today? He must not be. Oh, you moved. You're back there now. Ben's deciding to sing. Ben, how can I find the radius? Ben always sat right there. That's why I was looking right at you, Todd. Ben, how can I find the radius of one of these circles? My middle size ones.
Divide the 24 by 2.
So if we divide it by 2, that will give me this distance across, just like what I had over here. That halfway across is 12, or halfway across is 12. But that would be like the diameter of one of those circles. So what do we do then, Ben? We divide by 2 again. We get that this radius is 6. So now, my area formula is going to be pi times 6 squared. What's 6 times 6? 36. So we get 36 pi, but how many circles do I actually have up here? 4. So we're going to take this and multiply it by 4. And you might even notate that that's how many circles we have. And this comes out to be 144 pi inches squared, just like my first design was. Mia? No, what part? So I start by knowing my formula is always going to be pi times the radius squared. So instead of writing the new formula again, I just plugged in my radius of 6. I plugged that in for where the radius would be, where the r normally is. So you plug in there, and then that squared is 36, which that's where the 36 came from, was squaring the radius. And then because I actually have 4 circles, I have to multiply by 4. Make sense now? So that multiplication by 4 is just because we have 4 circles. It's my number of circles. Yeah, so really, we can kind of ignore the pi for a moment, because I can do 36 times 4, which is the 144, and just keep pi, because we're just going to keep pi how it is. We don't really mess with it. We just carry it along with us. Then, for my last one here, dudes, I'm using cards. I'm sorry. Nick, how do I find the radius in one of these circles?
You do 24 divided by 3.
Yeah, so first we do 24 divided by 3, so I get one of the boxes, like one of the edges of the boxes, which gives me 8. But that's actually the diameter, so my radius then becomes 4, because my radius is always half the diameter. Does it make sense how we find that radius? I do the same exact process. Area equals pi times, now it's 4 squared. So that'll be 16 times pi. But then, because I have 9 circles, we multiply by 9. And again, get 144 pi inches squared. So guys, the really cool relationship that you should see here is that no matter how many circles I put in there, I could do 4 wide and 4 tall. I could do 16 circles. I could do 5 wide, 5 tall. I could do 25 circles. No matter how many circles, if they edge to edge take up the whole as much space as they can, they will always have the same area. Mia? Or you can just write it right on there. If you weren't what? Oh, yeah, I thought you said if you weren't in the room. I didn't hear you say run out of the room. Yeah, I had a bunch of post-its back there. I think there still are some.
So if you take that big circle and measure it on all of them, will it still fit in that circle?
Yeah, so if you've ever made cookies, like really made cookies, normally when you roll out the dough, it becomes a big old circle, but then you punch out smaller circles, and you keep doing that. You'll ball it back up, roll it out, punch out circles. So if you imagine this big green circle to be a dough ball that I can then punch smaller circles out of, I could punch 4 circles of this size, like 4 cookies, and that would use all of that dough. Or if I make smaller cookies, I could punch out 9, and that would use up all of the big one. Or I could do 16 or 24, but they keep getting smaller.
So they equal the same thing.
It's the same area. They take up the same amount of space. So if I was printing a shirt, they'd use the same amount of ink. Alpha?
I got some questions. How did we get this thing?
It's our radius. So we took the whole distance across of 24, cut it in half to find the 12, and that would be our diameter. So we cut it in half again to find the radius.
Oh, I was confused. I made a division on 12 now.
How do we find the 12? Just same we just cut it in half though.
And my second question was for the plan C. The 16. How did you get it?
Because 4 squared, thank you for these questions. 4 squared, my radius was 4. When I square it, that's 4 times 4, that's 16. And then because I have 9 circles, I'm going to write that in different color. That's why we multiply by 9. That's why over here we multiplied by 4. Colin?
Can I say something about the shirt printing?
Yeah.
My uncle prints shirts.
Nice. What company does he work for?
He has his own company.
Very nice. We might need to get connected with him for some Phoenix shirts.
What do you mean connecting with who?
He just said his uncle prints shirts.
Oh, tell him to put me on Mr. Shirt.
So if you were paying attention, you'd
Sorry.
not have to ask what's going on. All right. Who here runs track?
Oh, I'm about to do
Track
that.
and field.
I'm
So
doing
one of
track.
the things about track and field is the middle of the track where all the field events happen.
At the same
Do you
time,
know what the sign up sheet is?
it's more long.
We done? Okay. In the middle of the track where all the field events happen, and sometimes they don't happen in the middle of the track, but where I came from, like that's where a lot of people, there was a lot of activity going on in the middle of the track. The grass gets beat up, like gets really, really messy, especially because in the springtime it's really muddy, like it rains a lot. So a lot of times we have to reseed the grass. We have to put down new grass seed so new grass will grow. Because old grass, once it dies, it dies. Like grass does not restart itself. You have to put more seeds down. So we have our track that goes around here. Now, most people say that a track is an oval. That's not really true because
Oh, yeah,
anyone
because-
run a 100-meter dash, the short races?
Yep.
Do you run around the curve or you run the straight line?
You run the straight line.
The straight line, right? This side and this side will be normally 100 meters long, and it's straight. Because if you run a race that's longer than 100 meters, let's say like a 400 meter dash or an 800 meter or a relay or anything like that, do you guys all start in a straight line? No. Can anyone explain why there's a staggered start? Nick, you might break your arm.
Okay, because like the person closest to the center, they have like a smaller area around, where the person on the outside has like a bigger area around.
Yeah. So if we imagine this room as a circle, and actually let's imagine this room as a half circle, and this desk corner is the center point, or quarter circle, or whatever you want to say. If I'm standing this close to the circle, and I want to go, imagine a quarter circle, okay? So we've got a radius coming out here, and a radius coming out there. If I want to go from this radius to that radius, pretty quick, so I'm close to the middle. But if I'm further away from the center, and I want to go from this radius to the other radius, I've got to walk all the way over here, and it's way further. So that's why we stagger the start, so that everybody actually runs the same distance at the end. Like when you finally reach the finish line, everyone will have ran the same distance. Yeah, if you run on a track, that's what they do a lot of times. Yeah.
Is that why is that why racers start at a different point?
Yeah, so the person closest to the middle would be the furthest back, and the person to the furthest outside will be the farthest forward.
I thought it was always because the person in the last was faster
Nope.
than everybody
Yeah,
else.
that's what a lot of people think, that it's some kind of like handicap, like they do in golf or those things, where they give you like, you know, because you're not as good, we'll give you some extra or whatever. That's not at all. This is so that when they all run, because the outer person runs further, the inner person runs shorter because they're closer to the middle.
Okay.
Oh.
That's why that happens. That's why we do that. So when you watch the Olympics or when you go support your friends at track, now you know why there's a staggered start. So that was just a little aside so you understand more about track and the mathematics behind it. So now we need to get back to our grass seed. We need to plant grass in this whole space, but we also need to plant grass in this space and in this space, because all of that's the middle of the track. Because the track would be shaped like this, and everything inside of it's grass. So what shapes do we really see up here? What shapes do we really see? What do we see? What shapes?
Okay,
It's not your card, but
B team. Well, we see a circle and a square.
now what do you mean you see a circle? I don't really see a circle. I'm getting up.
Okay, so what we have here is not an oval. An oval would be like this. We have a circle. Like if you took this big block out, a circle and a circle.
This is why I like what I nicknamed you. I kind of nicknamed you guys the video game generation. Some of you are really good at thinking like Minecraft or that sort of thing. Where I can move whatever I want. I could take that and I could put it over here. So in Ty's head, he took this half of the circle and this half of the circle and realized 2 halves make a whole. Oh my gosh. So what we really have is a circle. Continue.
Okay, and we also have a square.
Well,
It's a rectangle. Sort of a square, okay?
yeah, rectangle.
4-edged thing.
Columbus.
So here we have the radius of this circle.
Ah, we've got
but
the radius.
Also, we have half of
So
this.
that's the most important. Thank you for that. That's the most important thing we have to identify.
And you take it, multiply it
This
by 2, and you
Hold on, I'm gonna come back to that. This radius, it goes from the center point to the edge. If you did not immediately identify that that's your radius, jot a little arrow to that or something and put that's R. That's our radius. But also, that radius is not stuck there. I could draw a radius here. I could draw a radius here. I could draw a radius here, which is exactly what Ty is saying, B-team. He's saying that if that is the radius, that's half of the width of the rectangle. So we've got to decide whether we want to do our circle first or our rectangle first. Huh?
Squares are easy.
Rectangles.
Rectangle.
But the rectangle's easy, so let's do the rectangle. So our area is going to be the length times the width. I know that the length is 85, but how do I find the width? I take this radius and double it. So 36.4 doubled is going to be 72.8. So this area, when I calculate it, what do you get when you calculate it? It's sad that not more of you have calculators to help me out with this. What do you get? That's not for the middle, for that rectangle.
16, 160, no, 100,000, what? 60?
No.
6,188.
There it is, 6,188. What's my label?
Area, no.
Meters
Meters squared.
Did it.
Oh yeah.
Now we're going to do our circle.
Someone else do it.
So, our circle I'm going to color in blue just so we know why I'm doing it blue. So, area is pi times the radius squared. So, I'm going to have pi times that 36.4 squared.
Equals 3.14 times 113.24.96.
What? 113?
Wait.
I don't understand how you're saying these numbers.
134.96.
I'm going to check it.
Yeah, it is. 3.1.
It's
4160.37.
Guys, I think you did 36.4 squared, but I don't think you multiplied by pi.
I did.
Make sure that you type in.
That's what the guest teacher said.
Is it 10,000?
So she may have left it in terms of pi for a moment or forgotten to tell you, but understand we're ignoring what happened last Thursday. We are kind of acting like that never happened. It helps me manage my stress levels for guest teachers to act like that never happened. For the record, for what it's worth,
She did not know what she was
no,
doing.
she will never be back in our building. We've realized that she cannot deal with the Phoenix model. We will not see her again. She will go and help it others. It's too loosey goosey. just too open. Yeah,
Silly
it's
goosey-doosey.
that's you don't understand what we're saying. So this should actually be 4,160. When you do 36.4 squared, that gets you 1,324. Point
yeah,
like
that's right.
96.
Yeah.
So that 36.4 gives you almost 1325. Then you multiply by pi, and you get 4,000 approximately. I'm rounding. Yeah, I'm gonna let that round. Me?
She did that right now.
475.
You made a computational mistake. Check what you typed in. Go back up and check that you typed the numbers in correctly. So then to find the total area of the rectangle and the circle, class, we just
We add them together.
add them up.
I like how no one else adds.
Yeah, I know. Thank you for being the class B team. So I add these up, and I find that the total area is 48.
Meters
48. I thought.
squared.
Thank you. It's not right if it doesn't have a label.
That's not.
You
That's
should be
not where we
greedy.
start.
Now, I do not care if you already have work written down for the next one. I want to see you do the work for that problem.
I did.
If you already have it written down, do it again. Get it on a separate sheet of paper, post it, something. I want to see you do it again so that you understand what you're doing. Or check your work, process back through it, ask yourself, what did I do? Why did I do it?
Yeah, there is. It's up there.
There's one on there.
Yeah, there is. Up there.
That's a pretty big reach for some people.
And I'll do too.
Yeah. I'm always used to that.
It's a pretty normal reach for some.
I know.
All right, while you guys are processing through this on your own.
From there.
Hey, gentlemen. While you guys are processing through this, I'm going to call on people to help us so that I can write it up here. So, Todd, what would be the first part of this shape that you deal with, that you want to take
So-
care of?
Well, I'm about to explain what I did.
Yeah.
So I did 1.5 circle. A equals 1.5. 11 times R.
11. You mean pi?
Pi, no pi.
Yeah,
pi,
be careful
pi.
with that.
So it looked like
I know, you
Yeah.
got to make your handwriting so that when you go back and read it, you really know what's going
Yeah.
on.
Pi times R. 5 by. Sorry, I didn't write any of this.
It's okay.
Divided by 27.
So, first thing I'm going to jot down here is exactly what you said to begin with. We have a half circle. We do not have any other halves. We don't have any other parts of it. We have a half circle. So Todd wrote down that the area of that will be half of his area formula, pi times radius squared. So then, Todd, were you able to figure out what the radius of that circle was?
Sorry, I can't read my handwriting. I believe it's 27 point R or 12.
Ooh. So
12
this
point something. I don't know.
length
I didn't write that.
is 24. That's what it tells you is 24. So to find the radius, it will be this, which is just half of it, which is 12. So this becomes half of pi times 12 squared.
Yeah.
Right in there, there's a little green thing that says first aid. Top drawer. Yeah. So then, what is 12 squared? That's one that we need to learn. 12 squared. 144. So this becomes half of 144 pi, or half of 144 is 72. So that becomes 72 pi. And when I plug in 3.14, the area of the half circle becomes 226.
And 26? 08? So I did it right.
I'll round that off. If it's that close, I'll just round it.
I did it right. I did it right.
Yeah. Thanks, bud. I'm gonna round it. I'm not gonna care about that .08.
Second power though.
I thought I.
No, your label is to the second power. So it's 226 inches squared. Question mark.
I thought I got it wrong, but now that I know I didn't, I thought that you could just do the regular thing and then just divide it by 2.
You can. You totally
Okay,
can.
good.
So we can either multiply by a half or divide by a 2. Either way is the same operation, really. Whether you multiply by a half or divide by 2 is the same thing. So now we need to deal with the rest of my window. So when I go to deal with the rest of this window, sorry, what shape is that? It's a rectangle. How do I find the area of a rectangle? Length times width. So, Alex, when you look at this rectangle, what's the length and what's the width?
The width is. Wait. 36, and then the length is 24.
It doesn't actually matter which we call which. One of those is the length, one of them is the width. Some of you have been taught that the length is always longer. I don't really care, as long as you know how to identify this is the one dimension, that's the other dimension. We've got how tall it is and how wide it is. So if I was looking at this as a window, I would call my 24 the width, because if I look at it, that's how wide it is. But then I would say it's the width and the height. Doesn't matter what we call them, it's my 2 dimensions. So that 36 times 24 comes out to be 864
Inches squared.
inches squared. So then to find the combined area, we just add them up and we get
1,090.08.
Give me 22 points. Wait, no, hold on.
1,090. What?
Wait.
Oh, if I'm gonna round that because it says to the nearest square inch, so that's why we're rounding. So inch squared.
So do we erase it if we have the 0.8?
You don't need to erase it, but just know that if it asks you to round, you should round. I am not going to worry about the archery problem. If you want to write out a solution and an explanation, because I guarantee she did not go over that very well, that is an exemplary option. If you turn that in with your test, that will bump up your test score. Like, if you maybe would have gotten a progressing, that might make you get a mastery. If you would have gotten a mastery, that will take you to an exemplary. So, if you want to do the archery target problem, please jot down what the colors are right now. If you care, yellow is in the very middle, red is next, and then blue is next outside of that. Question? I gotta keep moving.
Okay, so let's say the answer to whatever this problem is A. You could say that it was a bullseye.
What? That the answer was a
Yeah.
bullseye? I like it.
He
Wait,
looked over
can you
his
go back?
notes and I
I was writing
I
down.
don't get it.
It's up there.
answer's a bullseye because like
A bullseye, like when you get an answer, you've hit the bullseye, you've hit the target, you've like hit the mark.
It goes
So-
in. It goes in.
Oh, the bullseye is like the very middle.
It's the very middle that goes in.
So, you did not get to the back, so please flip to the back. We want to find the area of this shaded region. So when we think about doing this, Braden, what process kind of comes to your mind? Find the rectangle, then do what? Okay, then what? Find the rectangle, find the circle. Because guys, remember this half a circle plus this half a circle make a whole, well, it grouped them, but if I move them, it'll group them, it'll make it a whole circle. So what do we do then?
you can always call in B team. Well, you always can phone B team. Okay, so we find the area of the rectangle and the circle, put them together, then we subtract them because we want the area.
Don't put them together.
I mean the two other sides of the circle. I mean.
Oh, you mean to
sides
like
of the circle.
think about them too. I thought you meant like add them. So I want you to write down right now on your
And then
paper.
subtract.
Shaded will be rectangle minus circle. Because that's really what I have. I have a rectangle with the circle taken away from it or
I was literally
removed
writing
from
word
it.
by word what you said, and then I looked and I was like, oh.
You were writing minus.
Yeah.
So we need to start by finding rectangle and then find circle and then do the subtraction. So to find the area of my rectangle, so I'm going to abbreviate rectangle area equals how do I find the area of the rectangle, Ben?
Like that.
Yeah. Yeah. So what numbers?
4 times 3, which equals 12 squared.
4 times, not squared. It'd be 12 inches squared. Be careful you don't just say 12 squared because that would be something different. So now I'm going to do my circle area. My circle area I know is pi r squared, but now that gets a little difficult. I have to look back to the problem information. It tells me the diameter of each half circle is 1.5. Question?
Well, like when you said circle and width and before area, is that like
That's a circle colon area. Or this one.
yeah.
That's rect, R-A-C-T, abbreviation for rectangle.
Oh, okay.
I just didn't want to write out the whole thing.
The diameter.
So, a half circle. I want your attention for a second. A half circle has all of the characteristics of a normal circle. I can find the distance from one edge to the other edge through the center point, but the only issue is the center point is now like on the edge. But think about what would it look like if the other half of the circle existed, which ours does, it's just kind of separated. So it has a diameter and it has a radius. Even though it's only half a circle, it's got a diameter and it's got a radius. So if that diameter is 1.5, how do I find that radius?
Can we just divide by 2?
Yeah, we can just divide by 2. And that will give me that the radius is 0.75. So now I can plug that into my formula. Say pi times 0.75 squared. Now what you'll notice when I take a number less than 1 and square it, it gets even smaller.
Yeah.
Because think about it. 0.75 is 3/4, right? If you have 3/4 of a pizza, like your parents ate 2 of the slices, whatever, you have 3/4 of a pizza, and they tell you you can eat 3/4 of what is left. Do you get to eat the entire 3/4?
No.
No, you get to eat 3/4 of the 3/4 that is there. So that'd be 3/4 times 3/4. You would actually get to eat 9/16. But 9/16 as a decimal is actually. Did anyone do 0.75 squared yet?
Yeah.
What is it?
Yeah.
5, 6, 25.
Thank you. 5625. When you do 0.75 squared, you get 0.5625. So now I'm going to multiply that by pi,
Well, 3.1.
and that gives me 3.14. Thank you. 1.76625. So now I take the difference between them. So shaded will equal the 12 minus the 1.76625. And that gives me I believe 10.23375. Thank you for the verification. But it's not right
I know, because
Inches squared.
until there's a label.
I said that.
Good. If you said it good, then hopefully you'll remember on the mastery. So guys, tomorrow we are finishing that mastery. So we're going to take the whole class period. So please make sure the homework is posted. It's only 11 questions. We're not done. I have 5 minutes, but I just wanted to make sure I said that tomorrow we are taking your mastery. So please try to get that homework done tonight. It was already posted at AO, so if you had AO, you should have already had time to work on it. Now this next problem I love. Because first off, I had a bunny rabbit when I was a kid. And second off, it's a really interesting application.
She got one.
So you have just gotten a bunny rabbit. Now one of the dangerous things is bunny rabbits can run away real easy.
Yeah,
So,
my grandpa
you
made
need-
a shed for mine, and it ran away. Like it bit its
Yeah,
way out of
it
ran
burrows.
away.
So you need to put up a fence. You go in the garage, you find an old roll of fence that you see has 44 feet of fencing. So you think for a little while, you're like, well, I could make a triangle fence. I could make, like, really, I could make any
Octagon.
kind of fence. You could, set up a really weird fence. But,
Yeah.
I know. Thank you. You could make an oval fence.
Oh my god, either.
You could make a spiral fence that wouldn't really make a lot of
No.
sense. But after you think about this for a minute, you decide the only 3 options that really make sense would be a rectangle, a square, and maybe a circle. Because, we like circles. They're round. They're nice. So let's start with a square. Let's start right in the middle. Start with a square. If I have a square that is made up of 44 feet of fence, 44 feet of fence, what do I know that 44 actually is in regards to the square, Colin?
It is 4 times the length
Yeah.
each segment.
It's 4 times the length of each segment, or that 44 is your perimeter. Now, because this is a square, what do we know about the side lengths of a square? They're all equal. So if I take 44 and divide it by 4, I get that each side here will be 11. So to find the area of that is pretty easy. It's just 11 times 11, which is 121 feet squared. So you're like, well, I wonder if a rectangle could be better.
It'd be smaller. I just know from like the last couple.
I know, because we did it as a warm-up like a couple days ago.
Rachel, show up to the office, please.
You decided to make a pretty long rectangle. Pretty narrow. So, talking about math? If I have 44 feet of fencing, and that's my perimeter of my rectangle, that means that one length and one width will be half of that. So, half my 44 is 22. So I know that whatever A is and whatever B is, they have to add up to give me 22. Because then the total would be 44 all the way around. Gravity works. So, what if I made one of these 6? So then to add up to make 22, what would my length have to be? 6 plus what makes 20? Close. 16. 16 plus 6 gives me 22. If I double that, that'll give me 44, which is the perimeter. So my area here would be 6 times 16. 6 times 10 is 60. Plus 6 times 6 is 36. We get 96 feet squared. So right now, which would be bigger, the square or the rectangle? The square.
I already know the order.
It has more feet.
As rectangular objects go, the maximum area is a square. But if we don't care to be rectangular, I'm going to go ahead and write this down. I know some of you aren't going to, but that's up to you. My circumference would then be 44. Which then, that is pi times the diameter. When I solve for the diameter, I get that the diameter is approximately 14, which tells me that my radius is about 7, which then leads me to my area being pi times 7 squared, or 49 pi, which comes out to be just,
It has to be less than 121.
Well, what's 49 times pi?
No. He solved it.
153.86 feet squared.
I knew it from the beginning.
The biggest area you can get from any shape with the same perimeters is a circle. A circle is always going to give you the biggest area possible. We are finishing your masteries tomorrow. The video will be posted in about a half hour. Sure, but can you not yell over top of me while I'm trying to finish class? Like, you realize how rude that was right there? I've got one, thank you though. That was one thing that is pretty necessary.
Is this stress ball for me?